in this board work, I had some blanks for the derivatives in derivative land, the integral land, and we filled in all that we already have established on hyperbolic trig functions. So now we're going to take a moment and do one. So here it is. Is that showing up on this side?
Yes.
All right, so
There you go,
talk me
Johnny.
through this. Jonathan, what do you think about y prime of hyperbolic sine? Looking at the board, what will we come up with? Remember, this is just a constant, so he'll come along for the ride. And he won't be in the formula, so my orange doesn't write, it's falling apart. Okay. So what's the derivative of a times hyperbolic sine of x over a?
Okay, so you would use the chain rule.
Yeah, but
And
what function?
What cosine?
Yes, hyperbolic cosine
Cosine
of x over a, and followed
X
by,
over a. So that would 1 over a.
right, 1 over a. So this a will actually cancel out that one.
Oh,
So all we have
wow.
left is hyperbolic cosine of x over a. Did you get to that before we did?
Sure.
I didn't cross the A's out, but I
Alright.
did get down there.
Alright, now we'll do one integral, and then I'll finish up with the inverse hyperbolic trig functions. Alright, let's do the integral of the cosine hyperbolic of 2x times the sine squared hyperbolic squared of 2x dx. I have to smush because I got so much up on the board. The integral of hyperbolic cosine of 2x times the hyperbolic sine squared of 2x dx. We'll do this one out loud together so we don't have to pause the video. So you've been pretty well trained in your u's. So Morgan, what do you think the u might be? If it doesn't work out, we'll change it.
I'm gonna say sine h.
That would be
Hyperbolic sine squared.
right, because it's squared, I would pick that too. So u, so Brendan, if that's u, what's the du?
Would it be hyperbolic cosine of 2 hyperbolic cosine of 2x?
Right.
Wait, Miss Paul, are you keeping, are we gonna be keeping the sine squared? Like, would it be hyperbolic sine squared of 2x?
No,
just drop
not in
the
our
square.
u, not when I do u, but
Okay.
it'll come out now.
Okay.
So now we're gonna substitute back. Aaron or Brendan, Brendan, what's missing in here that we have to adjust for? Do we have exactly u du?
No, we need a 2 in there, so you have to
Right.
pull out a 1/2.
Alright, so the 1/2 comes along for the ride, and now we have an exact u squared, that's the hyperbolic sine part, du. So, Aaron, take the integral of u squared.
1/3 u cubed.
Alright. And when we put the substitute back in, can you clean it up for us, Jonathan? Put the original u back in and clean up the fractions.
What the original? Oh, so that would be sine. Oh.
1/2.
1 over 6
Very good.
times the sine h 2x
Right.
the third
Right.
plus c.
I'll put the third there, and that's all it is. 1/6 hyperbolic sine cubed of 2x plus
I didn't
c.
know it was the equal sign.
All right, so that is an example. One from derivative land, one from integral land. So I think you're set to go on the assignment that will involve that. However, there's another section. Are we timing this second one?
Yeah.
Okay. And that is, just like in regular trig functions, sine, cosine, tangent, they have inverse, the arc sine, the arc cosine, the arc tangent. These guys all have their inverse trig functions. I've never heard the word arc used with them. So if that's wrong information, forgive me, but I've always heard the hyperbolic, how do I hear it? The hyperbolic, the inverse, hyperbolic sine inverse, that's what I call it, or hyperbolic cosine inverse,
mouthful.
hyperbolic tangent inverse. So, can you scroll back, and I'll actually fit it in over here. What was the definition of hyperbolic sine from the very beginning? We might have did it in X, I can't remember. Can you scroll back, Morgan, and tell me, it had e's in it?
Oh. Oh yeah, okay, I know where it is. It's e to the, so it'll be e to the u.
I'll just do X for
Okay.
our discussion.
So
E to
e
the
to
X.
the x minus e to the negative x over 2.
All right. And do you remember, were there e's in the hyperbolic cosine?
Yeah, there were.
Were there e to the x in the tangent?
Yes.
How about secant, cosecant, and cotangent?
Yes.
All right. Since these are inverse functions, and in these regular hyperbolic functions, e to the x is there, what do you think, what function do you just guess out of the blue would be in every hyperbolic inverse function? Not e to the x, but, Brendan, what do you think?
ln.
Very good. All right. One of you very good. Anyway. All right, so I'm going to give you these. I don't have any more board space, so I'm going to give these to you, and you only have one copy, so you put it in your formula sheet and copy it in your notes, or vice versa, or just use it in your formula sheet is fine. So here's the definitions.
Here's the tape, Gianni.
Here, I'm going to show him the hyperbolic functions. So, need to tape these in. Can you show me where to put those so he can see them?
I'll just zoom up on them.
Okay.
That works really well, actually.
Alright, they're all in the frame now.
Okay. So you can see, Gianni and everyone else now, the ln's appear all over the place because these are the inverse functions of those hyperbolic guys. All right, so what we're going to do also while you're taping in is I'm going to give you the graphs. And if you look at your regular hyperbolic functions, if you turn them 90 degrees and flip them over, then you will see that these graphs do represent the inverses. So here's the inverse functions. All right. So here's Johnny. Here's the graphs of the inverse functions. And I already gave you the regular graphs, didn't I? Yeah, because we went around the room and talked about them. Remember that?
Yes, I
Yeah.
remember.
Alright.
And lastly, but certainly not leastly, just like these regular hyperbolic guys have derivatives and inverses, guess what? The inverses have derivatives. Just like, remember we just did on our test, we did the derivative of the arc sine and the integrals and so forth. So, same thing, blah, blah, blah. Jonathan, did you want to take this stuff in?
Oh, I have the tape you
Yeah,
gave
okay,
me.
well that's good, you can use it.
Yes.
Alright, these are the ones, here's all the derivatives and the 3 integrals of these inverse hyperbolic functions. So, how's that showing up?
Just a little bit. And we're good.
Okay. So Gianni, I have these handouts for you when you return in many moons from now. So, alright, so I have nothing else prepared except work on
Oh,
these.
yay.
And so it looks like a good, since we haven't done any work, I think one day we looked up, we did the hyperbolic sine of 3, remember we were using our calculator. And then we took some IDs and we did sine squared minus cosine squared equals 1. Or was it the other way around? Cosine squared minus sine squared equals 1. One of those two, we proved that. And then we went on into derivative and integral land and then inverses. And we really haven't had a chance to have a homework on any of it because we were doing other things. So therefore, the rest of our class will be spent on doing these problems. It looks like about 25 or so problems. So it's my desire that you don't take many home on this long break, but here they are. So would you shine a light over here, Brendan? Oh, you need to know what page it is. That would help.
Alright, I'll view the crowd until then.
Okay. The page is section 5.8, and it's page 398.
Paparazzi, Aaron.
398 is the page. All right. So Gianni, we're just going to spend the rest of the class working these problems. So hopefully you have a book that you brought home. So we could check on that and send it home, couldn't we?
He probably has it.
You think so?
Oh wait, no, he didn't have any.
Yeah.
I was thinking
We'll
he had
check
one.
on that and try to get you a book if that is needed. All right, so over and out. Have a great Thanksgiving, and we'll see you a week from Monday.
Say goodbye,
Bye-bye.
John.
Bye.
Wait, can I